algorithm, which is called A star search. A star search is to minimize the total estimated solution cost. Now here we are considering two things in A star search. First, this particular A star search function we are going to relate with the path cost plus heuristic. Heuristic is nothing but the cost estimation from the node to the goal node. From the node to the goal node, some cost has been estimated. That cost is HN. GN is my path cost. What is it? Path cost that we have seen earlier, that how we'll calculate the path cost in the uniform cost search. And by adding these two, FN will be calculated. And FN is estimated cost of the cheapest solution. Yes. FN is called cheapest cost, estimated cost of the cheapest solution through N. And based on this FN value, we'll choose the next node to explore. Based on this FN value, we'll choose the next node to explore. Okay. So this is the problem that we have seen in the uniform cost search. Right? In the uniform cost search, this is the problem that we have already been seen. So what happened here is we used to calculate the path cost, and based on the path cost, we'll decide which particular node has to be explored next in the uniform cost search. So when I'll use the uniform cost search, if you want to find out the detailed information about the uniform cost search, so you can refer to the video where I have talked about the uniform cost search and the same problem I have solved. So in that, what we have done is we have started from the starting node and we have to reach off any of the goal node, right? This is my objective. So previously what we have done is we have started with S. First we have explored S. So for exploring, I am just making it round. From S, we can go to A, we can go to B, or we can go to D. A, the cost of A is 5. Cost of B is 9. That is the path cost, and path cost of D is 6. Now, whose path cost is less? A path cost is less. So we'll explore A. Once we'll explore A, we can go to G1 and we can go to B. If I'll go to G1, what is the path cost? The path cost will be 5 plus 9. It will be 14. From A to B, what is the path cost? Path cost is 5 plus 3. It is 8. So instead of putting 9, we can replace it to 8. We can replace it to 8 because the path cost is less. 8 is definitely less than 9. Now, what are the path we have? G1, B, or D. So G1 is 14, B is 8, D is 6. So 6 has to be explored because this is having less. Now from D, where we can go? We can go to S. It has already been explored. We don't have to add again. Then we can go to C or E. If we are going to C, what is the cost? The cost is 6 plus 2. It is 8. 6 plus 2, it is 8. Now it has already been explored. Now it is in the frontier list. G1, B, C, E. G1, B, C, E are in the frontier. So which will I take? So what I told you is 8, 8, 8 are the same. So we'll take it as an alphabetical order. So let's explore B. When we explore B, from B, we can go to A. With what is the cost? 2. So 8 plus 2, it is 10. It is already 5. So we'll not, sorry, it is already been explored. So we'll not do that. C, we can go to C. 8 plus 9, 8 plus 1, it is 9. It has already been 8. So we'll not do that. So B is already been explored. Now the next one has to be explored is G1. C, and E. Which I'll choose? I'll choose C because C is having less and alphabetical it will come first before D. Now from C, I can explore S, already been explored. I can explore G2. For G2, what is the cost? 8 plus 5. What is the cost? Is 13. 8 plus 7. What is the cost for F? It is 15. Now, what is in the frontier right now? So we have G1, we have G2, we have F, we have E. So which will explore? E will explore. Why? Because E is having less. Now from E, where we can go? We can go to G3. D is already been explored. Okay, only one option we have. And this will give you the estimated cost 8 plus 7. It will be 15. Now what is in the frontier list? In the frontier list, I have G1, I have G2, I have F, and I have G3. Which is the less? The less is G2. Now G2 will be compared with the goal node. Yes, it is one of the goal node, and this will be the cost. So from S, where we can go? From S, we can go to A. From A, we can go to B. From B, we can go to C. Sorry. No. This is not the path. The path will be from A to D, D to C, and C to G. This is my path. 6 plus 2, it is 8. 8 plus 5, it is 13, right? So I'm getting 13. If I'll use this path, then what will happen? 5 plus 3, it is 8. 8 plus 1, it is 9. 9 plus 5, it is 14. Because it is 13, so I am taking this path. So this is my optimal path, okay, for the uniform cost search. Now let's apply the A star search. Now in the A star search, apart from the path cost, individual path cost, we have some heuristic, as you can see. This heuristic is the estimated cost to reach any of the goal node. This cost, which is there in the hexagon diagram, we have this heuristic value. Okay, so we'll take the decision based on the Fn, and Fn will be calculated as Gn, which is the path cost, plus Hn, which is the heuristic value. So Hn is there in the hexagon shape, and Gn is my path cost. So let's see how it will be calculated. Now we'll start with the S state and we'll try to go to any of the goal state. So we are starting with S. Starting with S. S has been explored, A, B, and D. If we are going A, what is the cost? It will be calculated as 5 plus 7. So 5 plus 7, because it is a Fn we have to calculate all the time. So Fn is 5 plus 7. 5 is the path cost and 7 is the heuristic value. So it will be 12. For B, 9 plus 3, it will be 12. From here to here, D, for D, 6 plus 6, 12. Now in the frontier list, I have A, B, and D. Now which one I explore? All are having the value, Fn value as 12, 12, and 12. Which I'll explore? I'll explore in the alphabetical order. So I'll go for A. Now while I'm exploring A, I can go to B or I can go to G1. What is the Fn for Gn? It will be 5 plus 9. 5 plus 9 is the path cost. So 9 plus 5, it would be 14. And what is the heuristic? Is 0. So 14 plus 0, it is 14 is my Fn value for G1. Now I can go here also. So 5 plus 3, 5 plus 3 is my path cost. It is 8. 8 plus 3, it is how much? 8 plus 3 is 11. 11 is my heuristic value. So previously it was 12. Now I'll change it to 11. So I hope you understood. Path cost. 5 plus 3 is my path cost. And what is the heuristic? Is 3. It will be 11. Now what is in the frontier list? G1, B, and D. Which I'll choose? Definitely B. Now from B, I can go to A, which has already been explored. I'll not go there. I can go to C. What is the path cost? Path cost is 5 plus 3, it is 8. 8 plus 1, it is 9. 9 plus 4, it is 13. It is Fn value. Okay. Now C is explored. Sorry, has been explored. Now what is in the frontier list? G1, C, and D. Who is having least? D is having least. Now D, from D, I can go to S, already been explored. I can go to E, or I can go to C. If I'll go to C, so what is the cost? 6 plus 2, it is 8. 8 plus 4, it is 12. So 13 will be updated to 12. Let's say I'm going here, so it will be 6 plus 2, it is 8. 8 plus 5, 15. Now D has already been explored. Now which is left? B, G1, C, and E. Now if I'll go from G1, C, and E, if I'll go, so which I'll choose? Definitely this is the less. So I'll choose C. S already been explored. G has to be explored. F has to be explored. So what is the cost here? The cost here, it will be 6 plus 2, it is 8. 8 plus 5, it is 13. 13 plus 0, it will be 13. Now F, 6 plus 2, it is 8. 8 plus 7, 8 plus 7, it will be 15. 8 plus 7, it will be 15 plus 6. 15 plus 6, it will be 21. Now the next is, it is over. G1, G2, F, and E. In the alphabetical order, I'll explore E. This is also 13, this is also 13. So if I'll explore E, it will go to G1. So what is the cost? The cost is 6 plus 2 is 8. 8 plus 7 is 15. 15 plus 0, 15. Now 14, 13, 21, 15, which I'll explore. Definitely 13, this is very less. Now if I'll explore G1, G1 is the goal node, which I found. Now I'll take that particular solution. So what is the path? Path is S to D, D to C, and C to G. This is my path. Okay. Now, this is the solution that we have done. Now you see, when I do some modifications in the heuristic, so whole solution would be changed. So this is your homework. The same will be there. Everything will be the same. Everything will be the same. Only difference is, now here you can see The previous graph, in the previous graph, what are the node that is explored? A, S, B, C, D, E, and then last G. This one, right? G2. Now here, if you also see A, B, S, C, D, E, G. So the node which is explored is the same. For this particular problem, the time and the space complexity, what the uniform cost search is taking and what the A star search is taking are the same. But when we do the fine tuning to any of the heuristic, then you see the drastic changes. Now, what we do is everything will be the same, but instead of this six, the value that I'll put is 5. What I'll do? Value as 5. Now, the problem is same. Every heuristic value is the same. This heuristic I have changed from 6 to 5. Now you try to solve this. This is your homework. The same problem you try to solve with the heuristic. Instead of 5, it will be, sorry, instead of 6, it will be 5. Then you can see that I'll not go here. That node I'll not going to explore. That node also I'm not going to explore. Only the path will go from D to C to G1. Okay. So this is how it will be work. And we can do the fine tuning here. We can increase here. So it will be 5, it will be 6. Okay. So let me do that. It will be more understandable. What I'm doing is I'm doing a modification, small modification in the heuristic value. This I made it like 5. This I made it like 6. Now, if I'm doing it 5, if I'm doing it 6, all the heuristics are the same. All the path costs will be the same. Now, in that, you will find the solution very quickly. So this will give you quick solution. So what do you understand by that? We can conclude like this. The heuristic that we are choosing should be more near to the optimal solution, more near to the solution, more near to the correct value. If it is more near to the correct value, the solution that we'll get, we can get the quick solution. Are you getting it what I'm saying? If the heuristic value that we are choosing is near to the actual solution or near to the actual value, then to finding the solution, it is quick. We can quickly get into the solution if the heuristic value is correct, near to the correct. It may not be the actual value, but near to the correct. Then we can get the solution as quick as possible. Okay, so this is your homework. You can take the screenshot